Hi Geometry. This is Unit 7, Lesson 1, U7L1, and this is on page 788 of our Geometry workbook. So let's take a look at number 1. In number 1, we're talking about chords. Chords are special segments that have their endpoints on the circle. So these first 3 pictures are all examples of chords. A chord is a segment whose endpoints are on the circle. And a very special chord is one that you and I call a diameter. Not only does it have its endpoints on the circle, but it also goes through the center. Below here, these are 3 examples that are not chords. This segment does not have its endpoints on the circle. This segment is a radius, but notice one endpoint is on the circle and one is on the center. That's not the definition of a chord. And this segment goes through our circle. The endpoints are not on the circle themselves. Let's move down to number 2, and we're looking at arcs that are on our circle. So arcs we name with capital letters. For example, if we name this A and this endpoint B, then this is said to be arc AB, for instance, and we write that with a capital A, capital B with an arc symbol above it. Let's do another one over here. Let's call this D, and let's call this E. Well, then we could call this arc DE if we wanted to talk about it, and then we can call it DE with an arc symbol above it to name it. What about this little guy right here? Let's put the letters D, F on this. And so now if we want to talk about arc DF, how do we know it's the highlighted blue arc in the picture and not the other side of it? Well, this is a minor arc because it's smaller than 180 degrees. If I wanted the arc on the other side, I would need a third letter. Perhaps we'll put an E over here. If I wanted to talk about the arc on the other side from D to E, finishing at F, I can name that arc D, E, F with all 3 letters. To tell the person that is looking at my circle, I want them to look at the other side of DF. But if I just use the 2 letters, I'm talking about the short arc between D and F. Notice too, when your arc is made up of the endpoints of the diameter, you really could be talking about either side technically because they're both 180 degrees. This is not an arc on a circle because it's on a parabola, and this is a chord from above. So the chord obviously is not an arc. Let's take a look at the next page. So on this page, we're going to start learning some vocabulary about our circle's angles. First of all, we have a central angle. A central angle has its vertex on the center. So in this picture, you'll see all 3 angles have their vertex on the center. So in this particular picture, let's identify these points. Let's call this A, B, and C. There are several figures I might talk about here. I might talk about the measure of angle ABC, and that would be my red angle that you see here. And the measure of it, let's say it's 95 degrees. We would say equals 95 degrees. There's another figure in this picture. Let me go grab my blue pen. I also have this blue arc out here, and the arc would be named AC with an arc symbol above it. I can also talk about the measure of an arc. The measure of an arc is measured in degrees as well, and my blue arc would also be 95 degrees because the measure of an arc is equal to its central angle. So if one is 95, then the other is 95 degrees as well. Let's look about this acute angle. Maybe we think this is 25 degrees. Sorry if it's hard to read that 25. And let's call this point D, this point E for the center, and this point F. Again, there are two figures. First, let's talk about the blue angle. This is the measure of angle D. Got to put the E in the middle. You could have put the F and D in either order, though. That doesn't matter. But the E, the vertex, has to be in the middle, is 25 degrees. If I read that, I would know I'm talking about the central angle. And then my arc, DF, and you could have put F first. It doesn't matter which way you do it. The measure of that, little m for measure, is the same 25 degrees. And then this is a diameter. Let's call it GHI. So both arcs on either side is 180 degrees. And actually, GHI, even though it's a straight line, is also an angle. And since it's a straight line, we say that angle has a measure of 180 degrees, as well as the measure of arc GI in this picture is 180 degrees. Let's talk about what's not a central angle. This angle is not a central angle. We're going to find it's called an inscribed angle. The vertex is not on the center. This guy is not a central angle. The vertex is not on the center. And we're going to find that this is called a circumscribed angle. My vertex is outside my circle. So let's move down to the bottom of this page. So we have a theorem that congruent arcs have congruent chords, and vice versa is true. So in this picture, I can see that the chord from C to B, so CB, that chord, is congruent to DE. Since those two chords are congruent, then I know that arc DE is congruent to arc BC. I don't know their measure right now. I do happen to know they are congruent to each other. Congruent arcs have congruent chords, and vice versa is true as well. So if segment DE with a segment symbol is congruent to my segment BC, then I know that my arcs are congruent as well. So let's make some problems out of this, shall we? Can you connect C to A and C to B, and D to A and E to A? If I say this is a 50-degree angle right here and a 50-degree angle right here, those are two central angles. Their vertexes are on the center. So find for me the measure of angle DAE. Find for me the measure of angle CAB. Find for me the measure of arc ED and the measure of arc BC. Oh, I'm sorry, that should have been an arc symbol. See if I can just erase if you don't mind. So that was BC, the arc. So pause this video a moment and find those measures for me, and then play the video again and see how you did. Welcome back. I hope you realized that both central angles were 50 degrees. I gave that to you on the diagram. And up above, we learned that an arc is equal to its central angle. So both of these arcs are also 50 degrees in measure. Awesome. Let's go to the next page. So on this page, it's just reviewing that we understand what a chord is, what we understand a central angle is, and finally, let's look at this diagram. If this is a right angle, then I happen to know the measure of angle DAE is something I can find. The measure of angle EAC is something I can find. And finally, the measure of arc ED is something I can find. So pause this video a moment, study this diagram with your 90-degree angle, notice both these angles are marked congruent, and then come back and see if you got the right answers. Welcome back. Hopefully you realize that this is a diameter, meaning it's 180 degrees. So if this is a right angle, I know the other side, both those angles have to total 90 in order to be congruent. So I know that DAE, the angle, if you will, on the top, is 45 degrees, and the angle on the left would also be 45 degrees. Together they should equal 90, so that 90 and 90 is 180 for the whole diameter. And then ED, I know that an arc is equal to its central angle, so it would also be 45 degrees. Thank you, geometry.